this is MTS 201. I don't know what the code is from wherever you're watching from. Alright, so application of integration under the subtopic volume of solid shapes. Then using the disk method and the washers method. Alright, so this is what we're going to be talking today. So we are going to be talking about these two methods. So application of integration, then under the subtopic volume of solid shapes, using the disk method and the washers method. So literally, you see, there are some cases where you need to understand. So a case whereby you're having your region, so most times you're having a region on X. For instance, I'm having my region on X to be A and the other X to be B. Suppose I'm having this region on X. So the first thing is you draw this shape, you understand? So it depends. So I can have, let's say we have X to be 0 and we have this one to be like 3. Let's have this region on X. How do you sketch your diagram? So normally this is the line for X. So your 0 points from here, and let's assume 3 to be here. So that, which means that your line is going to be coming from this side, going up like this, then this is the distance between 0 and 3. Then at this point, so it points on the x-axis. So the distance between your this curve and the axis we are talking about is what we call the radius. So what we call the radius. So most likely at times they can have the small radius and the big radius. Like as this one is now, I can decide to have my radius like this, and I can decide to have another small radius here. You understand? It depends. So this is my big radius, and here I'm having my small radius. But the distance between the curve and the axis is what you call your radius. Understand? Alright, so this is it. So suppose I'm having y, for instance. If it was to be y equals to 0, x equals to, y equals to 2. Alright, so I'm still going to redraw this. Alright, so our y is 0 here, then you also have 2 here, right? So which means I am going to be having in this way, then this one comes like this, then I'm going to be shading like this. So this is the graph for your y. So that is very clear. There's no stress about that. There are many various ways you can always draw all this curve, but the thing is just have the idea of it. Alright, so I'm going to give us the formula for the disk method. So equation for disk method. So whenever you want to use equation for disk method, the disk method equation is the volume is equals to integral of a to b, then r of x all squared, then pi. Exactly. So integral a to b r squared then pi the x. That is it. So this one is for x axis. This is for your x axis. You understand? So maybe I should write it boldly so you can understand. Okay, let me write it here. for the Dix method equation, for the x-axis we have that the volume of any shape is equals to v equals to a to b, right? Then your r into bracket r of x raised to power 2 then pi dx. So this one is for x-axis. This is for your x-axis. So when your interval is ranging from a less than or equals to x less than or equals to b, depending on what you're having. So for the y-axis, you have v equals to integral of c to d. You know, after you have a, b, c, d, it's very clear. Then into bracket r into y, all carry squared and pi dy. Alright, this one is for what? For the y-axis. This is for the what? For the y-axis, where you have your what? Your a less than or equal, your c less than or equals to y less than or equals to what? D, for your boundary or for your interval. So that's it. So if you want to use the washer method, the washer method equation, washer's method equation is very simple. For the x-axis for the washer method, so that's going to be like integral of a to b, then into bracket rx squared minus, okay, you can put pi 2 because at the end of the day pi is common, minus rx, the small r, x squared pi. Alright, then everything having the x. This one is for the what? The x-axis. This is for the x-axis washer method. You remove the small arrow. So you know the small arrow is going to be small r into x. That's just the difference. Okay. So for the y-axis now, if it's for the y-axis, integral of c to d into r into y, r of y squared pi minus squared pi, then all having the y, you have the y, you write that like this, write this like this. So these are the formulas. You just have to master it, the disk method and the washer method. So this is for the y-axis, no stress. This is for the y-axis. Now at this point we are going to solve a question. So I have a question here. I'm going to solve question for the two whatever. Question 1. Find the volume of solids generated when the region bounded by y equals to 2x. The ordinates at x equals to 2, x equals to 4, and the axis, the x-axis is revolved through 2 pi radian. It revolved through what? Through 2 pi radian. Alright, so I'm going to be cleaning this. Alright, I hope there's no mistake on the question. Now, look at this question. It said find the volume of solid generated when the region bounded by y equals to 2x. The ordinate at x equals to 2, x equals to 4, and the axis is revolved through the what 2 pi radian. So no issues about this question. So you can see clearly that this kind of question is basically on the x-axis. So you wouldn't need to stress yourself much. So now, solution. Now, inside this question, it is very clear that our r of x is what y equals to 2. Our y of x inside this question is y equals to 2x. So your r of x is equals to 2x. Do you understand? That is, your r of x here is your y, which is equals to 2x. That is, r of x is equals to what? 2x. So at what? At x equals to 2 and x equals to what? 4. So no issues. Click on the below button. No issues. Now, what is the formula we are using? We are going to be using the one for the x-axis because we are having x-axis here. But before then, I've told you how to draw the diagram for it. Just draw your graph like this. So this one points here. Okay, we're having 2 here. Let's assume that 2 should be here. And 4 to yes. This is your 2. This is your what? Your 4 on the x-axis. So normally, it's not going to start from this origin. It's going to maybe start from, okay, let's pick it here. You can pick it here. You understand? So since it's not starting from the origin, so this is 0, this is 2, this is 4. So obviously, and even if you like, you can even do it like it doesn't matter anyway. It doesn't matter. So this is your 2, this one is shaded like this. So this is, then you can now let it be like a reflection here, right? So that you are going to be having your big R and you are going to be having your small r. This is for 4 too. So this big R, you can just leave it there anyway. So we can use the first method. This is your big R and this is your small r. So this place we are using the disk method. We are using the disk method to solve this. Now, using the disk method. Now, using the disk method for the x-axis, that's v equals to integral of a to b, then r of x, all carrying square, pi, the what? The x. Then we're having what? Integral of what? 2 to 4. Then our r of x is what? 2x. 2x squared, then pi dx. So we're having what? This equals to, this one becomes what? 4x squared, then pi, then dx. So we are going to integrate this definite integral. Alright, so v equals to, you bring out 4, then 4, integral of 2 to 4, okay, s squared, 4 pi, 4 pi, s squared pi, alright, s squared pi.
You don't hear, Abby?
Any problem with you? Bad video me, Jenny.
Okay, well, see, I know you.
What is that? Give me video. Enter.
Now me you use that. Hey, why?
No problem, yeah.
Hey, why you move? Oh, me let's
stop. So from here we have our 4 pi. 4 pi integral of 2 to 4, then s squared pi.
I cannot wait for all this thing. I beg.
Now
I beg.
We now
already now.
Stop now. No problem. And we are now going to integrate this definite integral.
You should have told me now, honestly, that you
v equals to 4 pi. Then Yeah, now this pi is not going to be here anymore. So this is 4 pi. By the time we integrate this guy, we are going to be s squared plus 1 over 2 plus 1, right? So we are having 2 and 4. Okay, so no stress. So we now have what? We now have v is equals to 4 pi s cube over 3. 4 pi into 4 raised to power 3 over minus, there's 2 here, 2 raised to power 3 over 3. That will be 4 pi into, this one is 64. Abi, 16 times 4. That is 3 over 8 over 3. Alright, no stress. So now 4 pi over 3 into 64 minus 8. So at the end of the day, we're having 4 pi multiplied by 56 over 3. So this one becomes 224 over what? 224 over 3 pi unit what? Unit cube. So that's our final answer for this first one.